All right, I just got the nod, so we can get started. So this talk, originally, there was a different title. You are sitting in the correct room. I just realized that when I use this title, it's just too large for the PowerPoint presentation, so I changed it to the actual essence of it, building Kubernetes operators in Java, Jakarta EE, and MicroProfile. So who am I? Well, originally German, which you probably hear on my accent. Have been living in Sweden for, well, close to 20 years, and I'm working at a company called RedBridge, which is an IT consulting or IT services company. We also have a public cloud and premium hosting nowadays. Predominantly working with Java for the last 20 years, so why not build operators in Java, right? Use what you know. What I will talk about, well, some of you probably have heard about operators, but what are they used for? So that I will go into for like a minute or two, just so we are on a level plane here. Then what I believe might be subjective, but the parts of an actual operator when you use it in production. Eventually, I will go into why I want to use Java and Jakarta EE and MicroProfile to build my operators. And we have a little demo, and then we will just wrap up. But just as important as knowing like what we are talking about is why you're actually having the talk. I don't know if any of you guys, well, most of you look like you've been around for a little while, at least in IT, but you know those like ambitious young people, you know, that are working, that just joined your team. You gave them a task. You say, well, we need an operator for something. And they, of course, they immediately rush away. They check, like, how do you build an operator? And in a meeting with 15 other people, you get to hear this. You can build Kubernetes stuff only in Go, because Kubernetes is built in Go, right? Yeah, might be true if you only read the operator SDK, which happens to be in Go. But when you then have like a guy like me sitting in the same meeting room, then you might see a face like this. Is he serious? I think I have to teach him something. And eventually I just tell them, well, please hold my beer. Now you see that there is a very significant difference between this face and this face. And I want to believe about myself that this composed, interesting guy was me in that meeting. Yeah, the more composed version of myself. So why an operator? Well, first and foremost, we want to augment Kubernetes with our own APIs, right? We want to add something new to Kubernetes, something that it didn't do before, but that we want it to do for us. It's usually like manual tasks, like say you have an enterprise firewall with an API, and for your Kubernetes cluster or your applications in the cluster to talk to like something outside of that Kubernetes cluster, you actually have to open a firewall or something like that. And if you're working at a big company, you will probably have like some order form or something like that, even though there is a perfectly good API where you can just make this happen with the help of an operator. So when we then look a little bit deeper into this, like I very much promote that you actually have everything that is part of your application actually in your source repository. Like your code alone is not the only thing that's relevant. Usually there is so much like infrastructure and components and middleware and things like that that have to be configured up for your application to work. And using an operator that can automate the manual things that you would otherwise have to do yourself each and every time you deploy a new application enables you to have your infrastructure as code alongside with your code or in your code repository. Another case that you can see a lot, for example, if you use like the operator catalog, there is like middleware that will be managed for you. For example, a database, you want to take a backup every night. You want to have the database to be set up for you, etc., etc. So instead of you doing the Helm chart and like creating a cron job or something like that that fetches like the data that's in the database every night. You can have like a very nice operators, and there are very nice operators around. I think I mentioned it before the other guys joined. For example, the Streamsy operator is written in Java, but that thing is like almost an application in and of itself. And another use case for which I have used it is, for example, if you need external data that you want to feed by any standard means to your application, like through a config map or secret or something like that. For example, you have EKMS. Then you, instead of having each and every application tell them to, well, use this API to fetch it, you could just have a resource in Kubernetes where you say, I will always need, for example, those keys or whatever it is, and populate a secret that I can simply mount in my pod. I know this is up for debate. Some operators have a lot more. Some operators have fewer things. But the core thing in an operator is the controller that has the reconcile loop. That's the thing that will check the desired state and make it the actual state. We have validation, because it's really difficult to reject something once it's in the Kubernetes cluster, once it's stored in the etcd database. We want it to be self-documenting, because when you are there and you are trying to use that operator, you don't want to guess what an attribute means. You want the thing to tell you, like, how do you use that? What does this attribute in my resource actually mean? How do you use it? Etc. Depending on how important that part is that you are acting on in the controller, you definitely should have failure handling and HA. We need to handle deletion, and we need a custom resource. A very simple explanation is that, like, any operator has a controller, but not all controllers are operators, and usually the defining difference is that the operator gives some new API to Kubernetes, while a controller can operate on the things that are already predefined in Kubernetes. And this you can write in Go, or Java, or any other language. And as it so happens, you can do that with those things also. When it comes to self-documenting, well, it's simply an open API scheme, which the API server will tell us later, like what's in the documentation. And the custom resource is just a regular Kubernetes resource. So let's look at the Reconciler a little bit more in depth. And I see Mark here, which is like a professional when it comes to Kubernetes clients. He will probably say this is not entirely accurate, but it's an easy way to explain. Kubernetes, we ask Kubernetes, we want it to list, for example, a pod. We want to list all the pods that are in the cluster, and we want to know if something changes. So we are watching that resource. So we are fetching the pods, and we keep watching to figure out, like, is something added, is something updated, is something deleted. Then in our own code, we are checking, like, what's the new desired state, and we will try to make it the actual state. When it comes to validation, well, there are two different types of validation. One is like the simple validation that you can have in OpenAPI. So, for example, you can have something nullable, required, etc., etc. You can have minimum values, maximum values, etc., etc. But for some more complex validation, you need to have like some code in your operator which can actually check those complex validation rules, and that's before admitting it to the Kubernetes cluster. If you remember what I said before, like once it's stored in etcd, it's difficult to do something about it. If it's wrong, it's wrong. So our validation hook will check it, and if it's okay, it will go onto the reconciler. If it's not okay, we emit a message to the user so that he can well, basically fix the error in its resource. We want self-documentation. I said that before. I don't want to guess what those different attributes mean. I want to know what they mean. And I would like to know that before I have to search in the controller source code or the operator source code, or search somewhere on the internet if there's some explanation like what this attribute actually means. And there are built-in tools, for example, in Kubernetes, in kubectl, in OpenShift, where they can actually build like an example for you in the UI, just as long as enough of it is explained. And even if it doesn't build an example for you, it can still tell you in the UI or kubectl, if you do kubectl explain, what you are supposed to enter in that resource. So what happens is it's basically checking the open API scheme and returning back an answer to us. So nothing more complicated than that. High availability. There is something called leader election in Kubernetes. What you can do usually is like, okay, I only start one pod and that pod will reconcile everything, but if that pod goes down, what do you do? Well, there will be, nothing will act on those resources that you're trying to change. For a very simple resource, like the one that I will show you in the demo code later, that doesn't really matter, it won't break the cluster. But if you are acting on things that are really core to the cluster, you can really bork up the cluster for everyone that is using it. So anyway, when we start the controller, we will do a leader election. We will create a resource, which is called lease, I think. And Kubernetes will then tell us eventually, okay, this controller with this lock ID is the one that's leading right now, so that one should check what's going on. And the reason for this, that we need to, but we can't have both of them acting on the same thing, is because they could step on each other's toes, right? So one says, okay, delete this, and both will see it, and both will try to delete it, and you will have to have all the error handling in your operator later, like what if it was already deleted, etc. So have two pods, but have one of them master, acting on the reconcile requests. And as I already said, you can't understate the importance of this actually working, because if you have an important resource, you will break the cluster. There's also something called pod disruption budgets. This won't stop you from scaling down your operator willingly. Like if you scale it down to 0, the pod disruption budget won't do anything about it. But if you're upgrading the cluster and the nodes are upgraded one after each other, then it will check the pod disruption budget and will see, all right, you always need at least one of those. So I will try to move the pods around and keep at least one alive, so that when the node is updated and is rescheduling pods or your custom resources, then there is at least one operator acting on it. There is a concept of ownership and finalizers. Ownership, I won't go into detail during the demo. The reason was that my demo initially was too long already, so I had to cut off the fat. But finalization can be very interesting. Say, for example, that you created a resource that says create a database in that Oracle database somewhere. When you delete that resource, you don't want that database to still, or that schema to still stick around. You also want that to be removed. So when we then trigger the finalization process, then the resource will not be removed from your cluster until it actually managed to destroy or remove the schema from that Oracle database that I was just talking about. And in the end, what's the custom resource? Well, we have the original API, we add the custom resource definition, and now we have an augmented API in Kubernetes. So we have something new in the API that kubectl or whatever else can act on. And that's, as if you remember before, that's like, to me, the simplified definition, what's the difference between a controller and an operator. So why do you use Java and Jakarta EE and MicroProfile? Well, I'm a Java developer. It's familiar to me. I know those tools. They're working for me. It's lightweight, at least if we compare to how it was 20 years ago. There are many competing definitions. If you don't like the first one, you can use the other one, etc., etc. We have, out of the box, all the specs and features and APIs that we need to talk to Kubernetes. And we have additional things in Jakarta EE that make our lives easier. Say, for example, that you have to put a message on a JMS queue. Well, then it's really easy to do that with Jakarta EE, right? Because it's already part of it. So we basically have all the features that we need to talk to Kubernetes and make our operator. All right. I will show you a little bit of the code and how it looks in OpenShift, etc., etc. We'll show you a little bit like how those custom resource definitions look, and try to actually talk to the cluster, provided that the internet is working well enough. Oh, that's fantastic. I had the problem before. Let's try it again. All right, you can see that. You can also see that in the back, right? So first of all, we have been talking of a couple of different things, right, in the walk, like what an operator consists of. And I said some things are not Java or Go or anything. So let's just look at the custom resource definition here. So here we are actually adding something to Kubernetes, a custom resource. We call it sample. We have short names, SMPL. We will tell in what group, in what API group our new resource lives. In this case, it's com, GitHub, Pfeifer, EclipseCon. We say that it's a namespace resource, which means that you can only create the resource in a particular namespace. It won't be a cluster resource, right? We use a couple of features like additional printed columns. This is something that kubectl reads. So for example, if you want to make it easy to show the relevant things on your newly created custom resource, then this is telling kubectl, okay, extract those things already when you do like kubectl get, as an example. And here's the Open API schema. Now I won't go into Open API. I guess most of you are familiar with it already. But here we are defining like all the properties that we are expecting, what they're used for. You see, I was a good guy and documented everything, and I said it's required, etc., etc. So all things that you will be able to see later. Would like to show you the deployment also, because I hinted a little bit that there might be at least some tips when it comes to Java applications in Kubernetes. Ignore this part. So when we start a Java application, usually we're trying to be like really neat. We don't want to overconsume memory, etc., etc. This might be something that on a traditional server you would never do. You wouldn't want it to expand and contract memory all the time. But for a starting app, when you start your Java application for the first time, those are really nice settings to do. You say that the meta space should contract and expand to its needs. You should say that the heap contracts and expands to its needs. And we say that the max RAM percentage is 50%. And that's actually the heap, because what I heard in many talks is that people are forgetting about the meta space, like file handles, stack sizes, etc. So you're somehow preventing the pod to crash because you leave enough for the native memory. And I could go much more into detail, but I don't think we have the time. But I will post the code later and their comments, so you can look at it and you can reason about it if it's feasible for you also. And another good thing that I also haven't seen that many times is like set the memory and the limit to the same thing. Most programming languages don't handle well if you pretend there is memory that simply doesn't exist. Java would crash. .NET would probably cache, like any application. And most of the applications, they look at the limits, not the requests, right? So set those to the same things. But on the memory side, on the CPU side, you don't need limits. It's a compressible resource. It will simply later try to figure out, set what you actually minimally need for the CPU. We're going down to the pod disruption budget. In this case, I say minimum available 1. We need to at least have 1 alive, even when nodes are updated and restarted. And finally, we have the validation webhook. And there we basically tell Kubernetes that, OK, if a sample, like the custom resource sample, is created or updated, then we are calling a JAX-RS resource on the path faux operator and on the service faux operator in the namespace. Yeah, the same. This only works over TLS. I created a throwaway CA certificate, so even though it's checked into the code, it doesn't matter to me. You can use it for whatever you want. But I didn't want to go through that part also. I guess most of you know like how to use a certificate. Well, let's look a little bit at the code then. Let's first look at the validation webhook. We have the usual, application for JAX-RS. And we have the validation resource. Also, plain and simple JAX-RS, we are using MicroProfile config, because what we want to validate when somebody is pushing the sample to us is if they're using cuss words. So the default cuss words that it will forbid is like poop and damn. And if you are familiar with MicroProfile, you can override this through environment variables. And that's what I've done here, because I realized, OK, some people might use the S word also. So I've augmented the list of things that I don't want people to be able to write in their custom resource. So what will happen when we send a sample? We have told through the validation webhook definition that we want to check it before it's going to the reconciler. We will simply get an admission and review object. It's like pure JSON that's coming to us. We will prepare a response, and then we will check if any of those cuss words that we don't want to have in the sample if they are in the message they are placing in the sample that the person is trying to create. And if it does, we will simply reject it. It says it contains invalid words and a couple of warnings explaining to us like exactly what words did we see that we don't want them to store in etcd. There is a little else case here. If for some reason we would get something else than a sample, then it would return this. But in a normal circumstance, that can't happen. We have a simple Kubernetes client producer that's really just so we don't have to constantly like new Kubernetes builder, .build, etc. So this is just an application scoped helper resource so we can inject the Kubernetes client everywhere. And the Kubernetes client that I'm using here is like the Fabricate Kubernetes client. It's like a really nice Java client that I've been using for quite some time. And then we can look at the controller, or the part that is controlling the sample resource. So first of all, we are preparing everything. We are getting an informer for our sample class, and the informer is not really anything that's like part of Kubernetes, but it's like a pattern that even the Kubernetes, the Go client or the original Kubernetes Java client uses. It's basically a cache. It's a watcher and a cache. It will watch like all the changes, all the events, for example, on a pod or a sample, fill up a cache where we can then later check, okay, what has changed? How does the pod look now? How does the sample look now? Et cetera, et cetera. And the reason why we do this is we don't want to put too much strain on the API server. We are simply watching for events. We are keeping whatever we have to reconcile around, so we don't constantly have to ask Kubernetes, okay, sample get, sample get, sample get, sample get. And then we have the leader election. Now, this is a bunch of code. I don't expect that you understand it. Sometimes I don't even understand all of this myself. But it's basically creating the list that I initially mentioned, and basically tells us to lead or to yield, like to basically stop listening or to start listen. Important part here is that we have injected a reconcile request handler, which is basically an event listener for the things that are coming in. And that is this class here, right? So when we get an add or an update or a delete, then we should act on this. So for example, if somebody has added a sample, then we want to act on this. If somebody has updated an object, then we also have to act on this. This delete case is, since we're handling it with finalizers, this will actually go through updates. So in this case, I don't have to do anything. And when we then come to the reconciler, this one doesn't really do anything exciting. What it does is that it takes the message from the sample that I just sent in, uppercases it, saves it in status, and is done with it. If we have not put if we haven't added the finalizer yet, then we are adding the finalizer, we are patching the resource, it's going through another reconcile cycle because we just have updated it, and then we are eventually coming back and doing what the resource, well, this resource should actually do. I even wrote, since I guess that some of you people might want to look at the code later, I added some comments. For example, implement something meaningful rather than just printing the message and uppercasing it. The same is here. When we are removing the finalizer, that's a signal to us that we should actually delete, for example, that schema in the Oracle database. So it's the same there, like implement something meaningful rather than just removing the finalizer. And in the end, you will see that the sample that we created, you probably know how a Kubernetes resource looks. It usually has a spec, it usually has a status, it has some metadata. All this, like the metadata part, we already get by extending the custom resource, which comes from the Fabricate Kubernetes client, which is like name and namespace and finalizers, etc. And then we have our custom definition for spec, where we really just have the message, which I will show you soon, and when we are interacting with the cluster. And we have the status, where we are recording the uppercase message, so that very little thing that our controller actually does, like, will be stored here. And we want to remember what generation of a particular resource we have already acted on, so we don't do it again. Oh, that you probably don't see, so we will try like this. So, first things first, we want to know what does sample actually do. And here we are coming to the documentation part that I mentioned earlier. We want to know what it does. We want to know how to use it. We do, for example, recursive. And it doesn't say very much. It just tells us it's a string, it's this and that. But to get some more, we can do spec message. And it will tell you the message to log and convert into uppercase. So, okay, now we at least know what that thing is doing. And we can add like additional information to like whatever field we actually define in the Open API scheme. So uppercase message will simply tell us, well, it's the same message, but it's reformatted into uppercase. So I prepared something here. We have two samples. We have the sample that will be stored as hello world and hopefully uppercased also. And we have an invalid sample, which the validation webhook should reject. So let's try this kubectl. Oh, we don't get that in. Contains invalid words. And it says there is poop. That's not good. We don't want to have that word in our cluster. Can run this a couple of times. The observant people of you, they will have noticed that there are MicroProfile metrics annotations on some of the methods. For example, we count how many times we have reconciled something. We count how many times a validation has been done. And I will show that very soon. I think we still have 5 minutes. And the valid sample, well, that went through just fine. So it passed validation, and the reconciler took care of it. So now we can do get, what was it called? Sample A sample in the namespace default. And there you see that thing that I mentioned before. We have additional printer columns. For most of us, this will be enough. We don't need to know the initial things. We just want to know, okay, like it did what it should. But we can look at it in a little bit more detail. So for example, this finalizer, that's what we added when we noticed that our custom resource that we sent to the cluster has no finalizer yet. So we added this. And as you know, when Kubernetes is trying to delete something, it looks at the list of finalizers, and when it sees a finalizer, it will not actually delete the resource until the finalizer has been removed. So we have to remove the finalizer, otherwise it won't disappear from the cluster. And this is our help to figure out, okay, we have to do something additional here, right? We see the observed generation, in this case the same as the generation that we have, and we have the message and the uppercase message. Just the last thing about the MicroProfile metrics, I will push some messages or some invalid samples to the clusters, just so we have something to look at, right? Yeah, observe and metrics. So we will see, since I started this, we had 7 total reconcile requests from one operator. I think it's really hard to see for you guys in the back because the light is actually directly shining onto it, but believe me, it's there. Not reconcile request, validation requests. Okay, we have 3 reconcile requests, and that, of course, just on one of the 2 pods, because one is the leader. What I usually do is when I have leader election, I will reuse the pod name because it's easy to find. So if you, for example, would just set a UUID or something like that, then okay, you would first have to check in the pod log, like which one is the one that's the leader if you have to debug something, etc., etc. So it's usually very easy to just use the pod name, and then you can check in the namespace where you have your operator, like who is the leader. So I check the leases, the faux operator leader, and the holder is CLRJG. And if we look at the pods, you will see that the first pod of those 2 is the current leader. Let's jump back to the presentation. 1 minute, so I think I will make it. Oh, okay. Well, in the end, don't be shy, don't be afraid. I mean, I know Kubernetes seems complex. There are a lot of moving things. In the end, it's an API server that exposes things that we already know. It's like JSON and HTTP. Of course, yeah, sometimes WebSockets if you do watches, etc., etc. We have Java, we have Jakarta EE, we have MicroProfile. We can already make Java applications run perfectly in the container world, right? And we have had the options to tweak everything that we need for our Java application to actually run optimally in constrained conditions. I know it has become a sport that like a pod should use as little memory as possible. We can do that already. We have done that for years. And as I said, it's maybe our new God OS, or basically the new operating system that we developers will see. We probably don't see like the underlying bare metal hardware, Linux, etc. anymore. We see Kubernetes. That's what we work with. It's our operating system now. Just bend it to whatever you need it to do for you. And with that said, there are a couple of links. The presentation, including the code, is on GitHub. And thank you so much for listening. So if you have any questions. Absolute silence. So thank you. Thank you very much.